I'm going to do escape. And if you have the gray screen one, now I'm working on the computer. And so with the computer, I'm able to use the mouse in a way that if you have the software you can use. But if you have the gray screen, you have to use the navigation keys along here. Or in this case, you can use the tab key to get to where you want to be, or you just press the corresponding numeral, numeral 1, and you have then this page. If you have the black version of this, inside, you see where my mouse is scrolling? Inside this is a little touch screen. How many of you have a laptop? You have a touchpad? You may not like to use it, but you've got it on your computer. Same thing here. This little piece in here, you can kind of experiment. If you take a very light touch and move right inside this little piece here, you can actually move your cursor just as I'm moving it here. So that's one of the advantages of the touch screen. But the click pad is just as good. Okay, I'd like to have everyone, whichever one you're on, to add a calculator. We have all of these opportunities, all these applications on the Nspire, and one thing that differs from the 84 is that we're able to define something in one format and have it be usable and show up in the others. So I can define something in a calculator page that when I open up a graphing page, I don't need to retype it. It's already there. And I don't have to then stop one application to get into the other one. I can just go from one to the other. So let's go to the calculator page. And I know it's a calculator page, one thing, because I've got a counter right down here. The other thing you're going to want to do is to go to menu. Menu is going to help you know what is possible, what you can do with that application. Come down to algebra. And let's just do a solve. I'll go back on that again. Go to menu, go to algebra, and then go to solve. And just press enter. And we have solve up here. Now we're going to solve something. What can we solve? I'll get this started. Let's try x squared. And let's say minus 4. What's missing? That's not an equation, is it? Yeah, you got to have an equation. Now, the equals on the black model is over here. I'm going to circle it over here to the very left. If you're on the gray one, it's in about the same position. There we go, up here by the control key. So either one, it's up there on the upper left, equals, and let's put in a 0. Now we have an equation, we only have one variable. Sometimes though we have more than one variable. So we have to tell what variable we're going to use, what letter we're going to use as our variable, and so we're going to have to find a comma. So look for the comma. On the gray one, it's over here between the lower two black keys, the enter key, it's the comma right here. If you're on the touch screen, go back to the touch screen. The touch screen, is that it? Yeah, right over here on the left side. So it's the opposite side. And we're going to say with respect to x. Press enter. You expect to see that? Yeah, I mean, I would think that that's what you expected to see. If you factored x squared minus 4, you would then set the factors equal to 0 and have x equals -2 or x equals 2. Now, I want to change that just a little bit, but I'm a lazy mathematician. Okay, I don't want to retype everything. So here's what we do. Go on either of these, use an up arrow key, and notice how when you use an up arrow key, it selects something in the history that we've been to. Hit the up arrow key a second time, and we now have selected that last command, and that's kind of like a copy happening. I'm going to paste it down here in my entry, my next available space, by hitting enter. we're going to use that. That's a really handy thing to have. Now the 84's new operating system can do this too, but before we were not able to. Okay, move the cursor in any way you want to. Move the cursor to the subtraction sign. Find your backspace delete key. It's in the same position. Have you noticed that when I press a key, it shows up red? Okay, that kind of helps. It's a nice visual. And I'm going to put in plus. I'm going to add x squared plus 4 equals 0. Press enter. What happened? Why? Yeah, we're in the real numbers. Now, can we solve this if we use another set of numbers? Yeah, called the complex numbers. So let's go back up, grab that one more time. The last one we had there, we'll just grab the one we had. Remember, we select it, and then we press enter, and that's a paste. Yes?
Mine doesn't say solve when it comes up, it's just blank.
Okay. What we needed, you need to have that word solve there. You can do that for yourself by just typing the word. Now, I want the rest of you, though, I want you to move your cursor to the left side of the word solve. What set of numbers do we need to use to solve this? Complex. It begins with the letter. Type the letter C. Okay, called the complex solve. Press enter. Did you get solutions? Yeah. Okay, so this is part of the computer algebraic system, the CAS, computer algebraic system that we have in here. Okay, I'm going to press enter also, and there are my solutions. Okay, so we have the ability to have all the symbolic answer stuff come back to us. I want you to do one more thing. Go to menu, go to actions, and go to the top one there called define. Menu, actions, define. Press enter. Whoops. I already had it there. Okay, so when you press enter, you get the word define. Could you just type the word D-I-F-I-N-E? Yes. Be sure, though, that you have a space after that word, and the space on the black model is right at the very bottom of the letters. If you're working on the click pad, it's also down here at the very bottom as well. Okay, now when we do functions, what's our function notation? How do we define, how do you know it's a function you're working with? That's this first section we're going to talk about, section 1.4, is functions. So this is a nice lead-in to this. Ever hear of f of x? Yeah, okay, that's our function notation. Now, we're going to be able to do more than one function when we start graphing. So instead of having f of x, we're going to have f1 of x, and then we can put in an f2 of x and all the way up to 99 if we wanted to. So let's type f1, and then we look for the set of parentheses of, now notice, I love this about this technology. It puts the right parenthesis there too. Remember how on the 84 you'd have to count how many lefts to be sure you have the correct number of rights on it? Okay, this comes along with it, so I like that we can have that already there. So we have f1 of x, move the cursor outside of that, find the equal sign, and we're going to make this pretty simple. We're going to use x squared. And press enter. Done. Don't know what we've done, but we've done it, whatever it was. Okay. Let's try something though. I want to find the value of f1 of pi. So I begin typing f1 of, now when I type f1, did you notice that it got bold? It changed font. Okay, that tells me that it is defined. It is reserved. I reserved it to be the x squared function. So keep your eye on that. If it ever comes up bold, you know it's something that's been defined. So it's f1 of, I said pi. For you who are on the click pad over here, just above the off one, is pi. If you're in the black model and you hit pi, notice you have other things you could use also. So you might just want to keep your eye on that because you might want to use those. I'm going to hit escape because I don't really want to put that in there. F1 of pi. I should have something like pi squared. Press enter. There it is, pi squared. Is it the answer you expected to see? Be honest now, you didn't expect to see pi there though. You probably thought you'd see 9 point something. Okay, this is also something that I'm really emphatic about. That's known as the exact answer. The exact answer is pi squared. What we are used to seeing is a decimal approximation. And so when you do a web assign homework, sometimes they ask you for an exact answer and sometimes they ask you for an approximate, and you need to know the difference between them. So if it's an exact answer, it's going to have pi in there, or it's going to have the square root sign in there. If it wants a decimal approximation, how are we going to get that? Well, if you look above the enter key, you see a little squiggly, and if you look on the click pad and you look within the enter key, you see some squigglies, and in this one, they're blue. You know what the second key on the 84 does? We use the control key. The control is our second key, our second button that you're used to seeing on the 84. So if I want to get a decimal approximation, just press control and enter. You don't have to retype anything, control enter, and we get a decimal approximation. So we can have decimal approximations, we just have to know how to get them. By default, you're going to have this be exact answers. Okay, so what happened to this? I defined the function and, I don't see anything that came from it. Let's see what we can do with that. So go home, don't leave, but just press the button, home. Go home, and any way you can, get down to this icon right here that says graphs, and press that, and you should have a coordinate plane. Now, we put our function where? F1. It says F2. Where's F1? One step up, so you can use your click pad and go up to F1 of x squared. I don't see it yet. No, you won't until you press enter. Now, I don't remember any of this stuff. How am I going to do it on my own? Well, don't worry. I'm going to teach this to you again on Thursday, and again next Tuesday, and so forth and so on, until it becomes second nature to you. So don't feel like you have to know all this. By the way, I love technology. Can you tell? Okay. There's another piece of technology that I just learned over the weekend, and I'm using it because I have to be gone a couple of times this semester, and I always hate it when I think that I'm cheating you out of some education. So I'm recording my lectures, and this one's being recorded right now, and you're all going to help me out by as soon as I send you an email saying it's on YouTube, you're going to go find it. And you're going to then let me know if you were able to download it and to listen to, at least don't listen to all the thing, but parts of it. So I'm going to be downloading this piece of it. So if you really need to go back and listen to this again, you'll have an opportunity to go through this part again, if everything worked out okay. So we'll see how that goes. But yeah, I will have lectures recorded for you if I have to be gone, so that you can just go to YouTube and hear my lecture. And then you won't feel like you're being cheated out of any education. Because you don't want to miss a class, do you? Oh, you really don't. Okay. Anyway, everyone got this now? And so if you don't know how, if you're being panicky because I don't know what's going on, that's okay. You'll have time. You'll be able to go back and get it done. For now, though, since I've given you a chance to kind of take a deep breath and we're going to move on, I'm going to teach you one of the most basic moves that we have to know how to do in order to really learn a lot of the mathematics. It's called grab and drag. Most of us know how to do that. If you have a computer, you have some sense of how to pick something up and then move it around the screen. So we're going to do that here. I want you to move your cursor. First of all, move your cursor to where it says label. Everyone had a parabola on the screen, I take it, and has that. If you move the cursor to where it says label, you see that hand that looks like it's open? Now, if I have the hand open and I want to grab that label, and it's like the bottle, I can't pick up the bottle unless I take the hand and do what? Close it. Simple as that. I've got to close the hand. So, to close the hand, if you look at the center of the, click pad, or the touch pad, you see a little hand that's closed. Now, if you look at that, it's in blue, if you're on the gray one. Anything in blue, control, and then press that button. So you do control, click, and that hand is going to change from open to closed. Same thing's going to work on the black model also. And we're going to move that. I'm going to move this all the way down to here. And then to let go of it, press enter. Okay, that's one. Grab and move, and we just have the hand, control click, it closes the hand, and then we can move it around. When you get to where you want to, you press enter, and that releases the hand. Take the cursor again, and this time move it to the arm of the parabola. It's a little tricky when I'm on the, there we go, on the arm of the parabola. I don't know what you call that cursor look. I call it the funky cursor. Okay, whatever it is, it's there. It's the same thing as the open hand. I've got to close that. And so to close it, we do what? Control click. So control click if you have that funny looking cursor. And when you do control click, you can do right and left. What's happening to the parabola when you grab the arm of it? Yeah, we call that a size transformation. What's happening to the equation of the function? Changing also. So we can look at, when that coefficient is really, 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 really large, the parabola is almost vertical. When it's really close to 0, it becomes, in fact, it can become 0. And if I continue bringing it down and that coefficient's negative, the parabola is upside down. Okay, we know that from algebra. Now we can actually do that. But the equation changes as we do that. Yes?
What if I don't see my equation on the bottom of the screen?
Oh, it kind of went off, didn't it? Here we go. We have to undo. It's somewhere. I don't know where, what direction. So let's undo. To undo, you can do Control Z, or you can do Control on the escape, Control escape, Control escape, and you will undo it, and eventually you should see it. Now, I'm guessing that your label is still attached to your, when I say attached, it's moving as your parabola moves. If you take that label and put it down where I have mine, it's like it has a little suction cup with it. If you pull it away far enough, it breaks the gravity that's there. Okay. Now, take your cursor. There's one other move we're going to make, and that is move the cursor near the vertex. If you move it near the vertex, you're going to see another type of cursor. It's the crosshairs. It doesn't have to be right on the vertex, but it has to be near the vertex, and you get a crosshairs. I want you to pick up the vertex. Now, when you pick up the vertex and move it, what are you doing? Ever hear of translating? A translation, horizontal, vertical translation? Okay, so when we do that now, and we move the vertex around, notice your equation is also updating as you go through this. That's the basic move, class. Grab and drag. That's it. A lot of things we're going to do is going to be based on our ability to grab and drag something around and then observe what's happening as we do that. Okay. There's so much more I want to share with you, but I really want to get into section 1.4. So I'm going to save the next piece until Thursday. We'll go through some more of this with you right now, but these are the basic moves. And there's more, but if you can practice those and come in on Thursday and feel like, yeah, I can pick something up and move around the screen, okay, we can move on from there. Okay. In your in Blackboard, how many of you have gone on Blackboard for this course? Okay, did you find course documents? Did you find chapter 1? Did you see section 1.4? Did you see the lecture notes? Did you? I think I have a tag on that that says, please bring a copy into class. It's supposed to be available. Did anyone see that? One person did. Okay, so I know it's visible if one person can see it. What I suggest is that you bring in copies of my lecture notes that I have posted there, because I don't want you sitting there writing everything down. When I was sitting where you are many years ago, all I did in class was write. I never thought. And I'd have to go back and try and make sense of my notes. I don't want that to happen. So I make these notes available to you so that you are able to keep your brain thinking about what we're saying and doing and seeing, and not just trying to get words down on the page. Okay, so please bring copies of those. Right now, you should have available to bring in sections 1.4, 1.5, and 1.6. I will tell you, we're going to spend quite a bit of time with section 1.5, so please bring those notes in, and we'll begin working on that on Thursday. Okay, we talked a little bit about what is a function. So right now, I'd like you to craft a statement in your notes. Just write down what you know, what you remember as a definition for function. Now, don't look it up in the book. This is not going to be graded, so don't copy it from the book. But just what do you remember? Okay, I want you to turn to someone. You got 3 people, most of you 3 or 4 at the table. Turn to someone, share your definition. Do they agree with you? Okay, did you agree? Yeah. Okay, here we go then. Give me 2 seconds. Okay, 2 of those started. Okay, so what did your tables say? Let's go with the second table there. Did anyone have a statement that you could?
We said an equation where you put in the number for x and so on.
Oh, could be. That's very narrow. Okay, not saying you're wrong.
Yeah.
Just a very narrow definition. Let's see if we can get a broader one than that. Two tables back from them.
Us.
Yeah.
I don't know, I kind of read it in the book.
Oh, that doesn't count. Okay. On the other side of the room, about the same table.
I don't know if this is right, but I just have a representation of a set of variables. Really broad.
That's a little too broad. Okay. Let's kind of get between those a little bit. How about the second table here?
We said a mathematical set of rules that when given an input and output to be determined.
A little too vague. Okay. How about way in the back?
A relationship between two variables.
Did you read that? I don't, okay. I didn't have a yes or no, and that's why I assume that's a yes. A relationship between, now you have to understand, I'm writing on this pad, and so my writing's not as nice as it is, which doesn't say much. A relationship between what? Two variables. Now we're on the right track here, but that's still not sufficient. Necessary information, but not sufficient. What's missing? I'll give you a little hint. Such that, not necessarily. Could, but not necessarily. True, but not complete enough, such that, and I'll put down part of what you said, because you're almost there. Every input value has what? True, but not complete enough. Now, I'm going to be talking to some high school teachers. What do you think they would say if I told them that my calculus students don't know what a function is? They'd just be devastated. You know that? They really would. They spend their heart trying to teach you this, but somehow it didn't take, did it? Now, when I teach, some of you are going to love this, others you're going to hate it, but when I teach, I really don't care much about the answer. I mean, I do, but the answer's not the end-all. I want to know that you understand it. And that doesn't come from memorizing a bunch of stuff. It comes from understanding it, working with it, seeing it in different venues, seeing it out there. I'm pointing to the walls outside, or the place outside the walls here, in your own life. So it's every input has an output, but that's not sufficient.
Doesn't it have to equal 0?
No. Okay. Well, maybe if I did something like this. This is called a mapping diagram. These are my inputs, and these are my outputs. Notice I don't use X and Y. No. Is that a function? You see, we can't talk about derivatives, which is all based on what is a function, if you don't know what a function is.
Is that a different output value?
Say it again.
A different output value?
Every input value has...
A different output.
No. I thought you had it. Thought you had it. Say it again. Every input has a unique output. What is that word unique? Why is that so important?
There's no function the same.
No function has the same output.
Oh, that isn't what you said. Every input, a relationship between two variables, two sets of data. Let me put that. I don't usually say variables. I say sets of data. I like that better. Variables is a little too restrictive. A relationship between two sets of data such that every input value has a unique output value. Now what happens if I take this, I'll make it green. What if I said this? Oops, come on. There we go. And I squeezed a 3 in here. What's the output value of A? Ah, is that unique?
Yes.
When you say 1 and 3, is that unique? No, it's not unique, okay? Because I've given A 2 output values, not just 1. So every input value has exactly 1 output value. Now, nothing says that we can't have 2 inputs going to the same output. It just says that we can't have more than 1 value assigned to a given input. And did you hear my terminology? I say input and output. Have you heard me say X and Y yet? No. I'm not using X and Y, especially in contextual situations, unless I have xylophones and yachts. Okay? Because I can put anything for inputs. I could have years, and that would be a Y. So my beginning letter would be a Y, not an X as we expect. Okay. Here is then the next thing. This is going to tell me if you really get it. Let's just focus on here. I say that you have observed or experienced in the past 24 hours. I'm going to change that. Everyone's taking more than this class, right? Some other class? Some of you have 3, whatever. Let's suppose that other class is English literature. Can you think of a function in an English lit class based on our definition, mathematical definition? Well, there's no numbers in English lit. English lit. A function. Example. There's no numbers. I'm not writing equations. Who said it had to be that? What does it say? It says a relationship between 2 sets of data. It doesn't even say numerical data, does it? It just says data. We call it categorical data. For instance, if I'm looking at the cars in the parking lot, and I have a Ford, and I have a VW, and I have a Mazda, but there's no Ford and a half, okay? There's no Ford and 3/4 or Mazda Ford 1 1/2. You can't go between them. It's either this one or it's this one. That's categorical data, okay? So if we allow ourselves to look at any sets of data, it just says that every input value, that stuff in the first set, has a unique relationship to something over in the output. So all the cars in the parking lot, I could number those parking spaces, and I could name them car 1, 2, 3, 4, and I could call the parking spaces A, B, C, D. Every car is assigned a specific parking spot. It's not numerical as you think of it in calculus, maybe, but it is a function. So English lit. English lit. Oh boy, what could we do for that? Well, let's say that our input is, well, how about titles of books? Can you think of more than one title of a book? Go with me on this and say yes, okay? Yes. Okay, we got title A, B, C, I don't care, what it is. And over here, let's say it is the initial copyright date. Are we describing a function? Could A have more than one initial copyright date? No. It's a function. Could B have the same initial copyright date as A? Yeah. Doesn't have to, but it could. But it's not going to have more than one. Okay? So a function. So we got to think outside of the classroom, outside of the math textbook. but it all comes down to that definition. And when we talk in this class about a function, we need to understand that we're looking at two sets of data. And we have to identify what is the input set of data. And it could be time, it could be speed, it could be distance, it could be years, whatever. And the output, we have to identify what that is as well. Okay. Again, the schedule I have for you is a floating schedule. That's why I'm not handing it out to you ahead of time. I will let you know when the tests and quizzes are, but right now I would like to do something else that's not in the textbook. I need everyone to, I'd like to only have 2 people working together, so when there's 3 people, you might go 2, 2, and then you 2 as a group, okay? So find someone near you that can be in a group of 2 with you. I'll give you 2. One paper for every 2 people. Okay, you guys know how you're going to pair up here? Yeah, we're going to have an odd number of people here. So he's going to be adopted by one of the groups here. Okay, we're going to Okay, now, I'm going